All right, guys, just a quick video to hopefully help you understand the gel electrophoresis part a little bit better of the workshop. So just as a reminder, we're looking at bacterial transformation as a whole thing, but the gel electrophoresis part, that's coming into play here in this diagram that we've referred to previously. So at this point, we've got the plasmid cut open and we've got our gene of interest that we want to insert into the plasmid. And we're hoping that that insertion has been successful and that we now have the recombinant plasmid. But there's no way of knowing because you can't see these plasmids. You can't see the little pink gene inside the plasmid. So we've got to have a test. We've got to have a way that we can test to see if the size of this plasmid has been increased. So that's what the gel electrophoresis is trying to do. Okay, so the results that you see of the gel electrophoresis test, that's the picture that you're given of what it looks like in the end. In real life, it is a little bit more interesting. This is just a photograph of the gel, but it glows fluorescent. It's quite pretty to see. But this is a picture of what the gel looks like. So the test that was done was a standard loaded into the first lane here. So that's S for standard. I'll talk about what the standard is in a minute. You've got the PCR product, which was the gene, the ANTR gene that had been copied multiple times to be mixed with the plasmid, and hopefully it has mixed with the plasmid. But the gene by itself, we want to know how big that is. So that's what's been loaded into this lane. The plasmid, so it's P for plasmid. We want to know the size of the plasmid to begin with. So that has been run here. And then the question that we are asking, or that is being answered by this gel, is this here. What's the result? What does the plasmid plus the gene look like? So that's what you've got to have a think about. What would that look like under each of those circumstances? So what will it look like if the recombination has been successful? And what will it look like if the recombination hasn't been successful? Because that's the test. That's going to be the answer to our question of if we've got a recombinant plasmid. So just looking at what a standard is, we can see that the lane labeled standard is here, and there's lots of pieces of DNA in there. And what the standard actually is a piece of viral DNA. So that would be just represented by this black line here, a piece of DNA, usually from a virus, that has been cut up with a restriction enzyme. And this is a piece of DNA that scientists know very well. It's been sequenced. We know exactly what that sequence looks like, and we know exactly where these cuts are going to be made. So therefore, we also know how big each fragment of the standard is. So we can see in this viral DNA, we've got a piece that is 23 kilobases long, and we've got the smallest piece being 2 kilobases long, and then all the other variations along the way. So when we chop up this piece of viral DNA, we know exactly how many fragments it will make, and we know how big they're going to be. So this is a control in the experiment. This is a known size piece of DNA that when we run it on our gel, we know that the biggest one is 23 kilobases. So when we see our gel at the end, we know this band up here, that is our 23 kilobase piece of DNA. If one of our unknown sizes runs to that same point, then we know it's also 23 kilobases long, because the same size DNA will run to the same place on a gel. So the question that we are asking in this experiment is, do we have a successful recombinant plasmid where the gene has been successfully inserted into the plasmid, or do we have the plasmid having resealed on itself and not incorporated the gene. So there are our two options. Okay, so in our second lane, the gene, that's this here. That's our gene that has been copied many times, and we're checking its size. So the way you check the size is, so we're measuring against the ruler to determine how far this band has run, and I measured that to about 47 millimeters. And 47 millimeters is really close to this one here that I measured at 48. So these two I'm going to use to estimate the size of the gene, and I'm going to estimate that it's about the same size as this one that measured to 48, and that piece of DNA at 48 millimeters, that's this one here. That piece of DNA in the standard, the 23 kilobase piece, that's the one that I'm seeing in the standard over here. So my gene must be about the same size as that piece of DNA. So I'm going to write that it is 23 kilobases. Oh, sorry, not 23, 2.3 kilobases. Same for the plasmid. I want to know how big the plasmid is. So it's been run in lane 3, and it's run to the same point, as far as I can measure, as this piece here, which is our 2.9 kilobase piece. So they've both run to 40 millimeters. All right, now we get to the question mark. So the question is, has our recombination been successful? Have a think to yourself for a second. What do you think we're going to see in this third lane if the recombination hasn't been successful? So if it hasn't been successful and we've still got the gene and the plasmid as separate pieces of DNA, what do you predict this lane will look like? If you need a second to think, then pause, because I'm about to show you. If that is the case, if we've got a separate piece of plasmid and gene, the third lane will look something like this. And can you see why? So if they haven't recombined, we're getting two bands for two separate pieces of DNA, and they're in exactly the same position as the plasmid and the gene separately, because that's exactly what you've got. You've got the plasmid being this bigger band up here, and it's separate to the gene being the smaller band down here. So that's what would happen, or what we would get as our results if we haven't been successful, if recombination has not been successful. But that's not what we see. So when you look at your results in the workshop, what you actually see is that. And if we measure this band that we now see, this new size band that we see in the PG lane against the standard, it's about the same size as the 5.2 kilobase piece. So we can estimate that the size of this P plus G, the plasmid and the gene, is 5.2 kilobases long, which works out really nicely mathematically, because if we estimate that the gene is 2.3 and the plasmid is 2.9, what is that added together? It actually equals 5.2. And so this is what we're seeing in that plasmid plus gene lane. You've got your successfully recombined plasmid, and that is a tick. Our recombination has been successful.